I'm going to talk you through how to approach answering this question on circuit components and their characteristics in relation to current and potential difference. So you were given this graph which shows two lamps which have had their current measured at a lot of different potential differences. Now, the important thing to remember about any graph which shows you potential difference against current is that the gradient of that line is equal to the resistance. Okay, so if you know potential difference and current, you can calculate resistance, because resistance is going to be equal to voltage divided by current. Okay, so we know that information, and we know the gradient of the line is equal to the resistance, or tells us about the resistance. So if the gradient is steep, then resistance is low. If the gradient is shallow, then resistance is high. Okay, so that's sort of the background information we need to think about this graph going in. So resistance is equal to voltage divided by current. The gradient of the line tells us about the resistance. If it's a steep gradient, then the resistance is going to be low, because a small change in potential difference leads to a big increase in current. It's easy for the current to flow. If the gradient is shallow, then that means there's a high resistance. A small change in potential difference only leads to a small change in current. It's not very easy for the current to flow. Okay, so question A asks us which of the lamps will be brighter at any of the potential differences. Okay, and it tells us to use the figure above to aid your explanation, which means we need to mention the graph in our answer. Okay, so in this case, we're thinking about what's going to make the bulb brightest. So the key thing here is it doesn't matter which potential difference we look at, whether you look at 1 volt, 2 volts, 10 volts. Lamp A has always got more current flowing through it than lamp B at the same potential difference. Okay, so if you compare the same potential difference for either of the lamps, then the current is always higher in A. Current, if you remember, is a measure of the rate of flow of charge. So if we have a high current, we've got more charges flowing past the same point in a given period of time. And the charges are the things that carry energy. So if my current is higher, that means more energy is being transmitted to my bulb every second than at a lower current. So in this case, the answer is going to be A. So this is a 2-mark question. So we needed to say is that A will always be brighter, as current is always higher. Okay, so we're referring to the diagram because we're describing why it is. Okay, that's the first marking point. The second marking point is that this means that there is more energy transmitted. Per second. Okay, now we can talk about energy transferred per second as being power. We haven't quite covered that topic yet, but we can still talk about energy being transferred per second. Okay, now part B, the lamp has, so the question is that lamp B has the higher resistance at any potential difference. Explain how the figure shows us this. So what we need to be thinking about here is this information relating to resistance is equal to voltage divided by current, and if the gradient is steep, then the resistance is low, and if the gradient is shallow, then the resistance is high. So there are a few different ways that you could explain this. So you could talk about the gradients of the line, but probably the best explanation is going to relate to this. Okay, so the resistance is always higher for B, because if we look at any given voltage, so let's say we look at 2 volts, so for 2 volts, lamp B's resistance is relatively low, it's less than 0.1. So I'd be doing 2 divided by 0.1. If I wanted to work out the resistance for lamp A, I'd still be using 2 volts, but now I'd be dividing by 0.3. So I'd be dividing by a bigger number, which would mean my resistance would be lower. Okay, so if we wanted to give this, to explain this here, we would say that lamp B has a lower current at every potential difference. So that would cover our first and second marks, because we're saying that it's true for every position on the graph. Final question is question C. Both of the lamps behave like ohmic conductors through a range of values of potential difference. Use the figure above to determine the range for the lamps and then explain your answer. Okay, so an ohmic resistor is one that obeys Ohm's law. Okay, so Ohm's law we use this equation to represent it. But another way of expressing Ohm's law would be to say that voltage is directly proportional to current. Okay. Now, on a graph, we know that something is directly proportional if the line is straight. Okay. So essentially, what we're looking for here is the points on the parts of the graph where the line showing the relationship between a potential difference and current is a straight line. Now, often the easiest way to do this is by literally putting a ruler onto your graph and looking for the parts of the line where it is a straight line. So if I line this up here, you can see that for the first part of my line here, from 0 to 2 volts, that is a straight line, okay? Or very close to. And the same thing happens if we look at the line for lamp B. Okay, so you have a straight line happening from 0 to 2 volts, and then it's after that point that it starts curving away from that straight line. We do that again over for lamp A, we see the same thing. The points line up on a straight line for the first 2 volts, and then it's after that point that they start curving away. So the part of the line, the part of the graph which shows the lamps behaving as ohmic conductors, is between 0 and 2 volts. So that's the first mark, from 0 to 2 volts. We then need to explain our answers. Okay, so we could talk about the fact that the lines are straight at this point. Or rather than talking about the lines being straight, you could say that at this point, voltage is directly proportional to current, or current is directly proportional to voltage. Both of those would get you the second mark. And the last mark is for relating that to what we mean by an ohmic conductor. So ohmic conductors obey Ohm's law, where voltage is proportional to current and the resistance of that conductor is fixed. So you could say at those points, R is constant. So that is how we would approach this exam question and how we would get all of the marks we need for it.